Hey guys, my name is Vince, and I will be doing the AP Calculus FRQ from 2004, question number 1, Form A. So let's get started. The traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f defined by f of t is equal to 82 plus 4 sine of t over 2 for 0 to 30, where f of t is measured in cars per minute and t is measured in minutes. So you need to identify that the function f of t is measured in cars per minute, which is a rate, so keep that in mind as we move through each question. Part A. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? So obviously you're going to need your units, and how many cars? That's a quantity, the cars. Your function is in cars per minute, so how do you get from cars per minute to cars? Well, you would integrate this function and you would get to cars. So that's basically finding the area under the curve. So part A, the integral of 0 to 30, which is your time interval, 30-minute period, of your function, f of t dt. Make sure to write dt, otherwise you will get points knocked off on the actual exam. Alright, now this is a calculator question, so you would do the integral of f of t 82 plus sine of t over 2, and I'm using x instead, x, comma, from 0 to 30. Your answer will be oh goodness, I think I've done something wrong. Oops. Oh, I forgot to multiply by 4. Here we go. And your answer is, here we go, 2,474.08. And they ask for in whole numbers, so you need to round that for 2,474. And your units, cars. Part B. Is the traffic flow increasing or decreasing at t equals 7? Well, keep in mind, increasing or decreasing, when you dig back into your calc memory, those two words will mean you need to do the first derivative test. So we're going to derive your function f of t and f prime of t. We start out with your function 82 plus 4 sine of t over 2. And if you have an 89 or Inspire, you could derive it on a calculator using the derivative function. But for people that don't have it, I'm just going to do it by hand. So 82 goes to 0 plus 4 times, you derive sine of t over 2. That's going to be cosine of t over 2 times the derivative of the inside, which is 1/2. This cancels, this goes to 2, so it's 2 times cosine of t over 2. That is your derivative. Now, you need to plug in 7, like they said, and you need to find, because they give you a point, you don't need to find your critical numbers. 7 will be your testing point. So, 2 times cosine of 7 over 2. And now use your calculator. And you get negative 1.87291. Your answer is negative, and that means it is decreasing. So they also ask for a reason, so be careful. So you need to say something like, because f prime of 7 is less than 0, the traffic flow is decreasing at t equals 7 minutes. That is your answer for B. Moving on to C. What is the average value of the traffic flow over the time interval 10 to 15? Indicate your units of measure. Do not confuse your average value with your average rate of change. That's different. Your average value is just your average of the traffic flow. So, when you look at units, traffic flows in cars per minute. So, when you find the average, it stays the same. Your units will stay the same, so it's still cars per minute. So now, what do? You need to know your equation. For average value, your equation is 1 over b minus a, integral of a to b. In this case, your equation is f of t dt. Don't forget that dt. And now you can plug it in. 15 will be your b, and a will be 10. So 1 over 15 minus 10 times the integral of 10 to 15 of f of t dt. t. Now plug that into your calculator. This is 1 over 15 minus 10. 1 over 5 is 0.2 times the integral of your function 82 plus 4 times sine of t over 2 x, comma, and your boundaries are 10 to 30. Oh, my bad. 10 to 15. It's close. The answer is 81.8992. And your units, well, your average value, it's the same, so it's still going to be cars per minute. That is your answer for C. D. Okay, what is the average rate of change of the traffic flow over the time interval 10 to 15? Indicate your units. So the average rate of change, this is what you can't mix up with average value. Average rate of change is just your slope. It's your derivative. And of the traffic flow, so if you derived your traffic flow units, you would go from cars per minute to cars per minute squared. So cars per minute squared are your units for this question. Your average rate of change, really, all you have to do is find the slope of these 2 points, like 15 in f of 15 and 10 in f of 10. So it's average rate of change, your slope between these 2 points. F of 15 minus f of 10 over 15 minus 10. F of 15, you need to plug in your calculator, 82 plus 4 sine x divided by 2, put a pipe, set x equal to 15, and you're going to get 85.752 minus, change it to 10, 78.1643 over 5, and we're going to subtract that and take this answer minus this answer divided by 5. That will give you 1.51754, which is equal to 1.518. And your units. So because you found the average rate, the rate of a rate, basically, the derivative of cars per minute is cars per minute squared. That is your answer, and you're done. Thank you guys for watching. I have provided some helpful links in the description below. So that would include the Khan Academy AP Calc integral questions, which is a link to a bunch of videos that Sal Khan did. They're very helpful, and he describes and he walks you through each calc-related integral question from the actual FRQs. I've also attached a link to FRQ 2009, number 2, Form A, which is a similar question to this question right here, but it's a little harder, uses different kinds of rates. Also, I've attached a video link to the TI Inspire video of this same question right here, FRQ 2004, number 1, and it's for all the Inspire aficionados that want to work on just using the Inspire and how to do this whole question on that calculator. Also, there are exercises from section 7.2 of your calc textbook, which include trigonometric integrals, and number 66, which is a very similar question, will help you very much, and where you apply your trigonometry to integration. It's a multiple step question and will help you a lot. It's very similar to this, and it's in the book. So I highly recommend checking all these links out, and once again, please leave a like, comment, or subscribe. I'm kidding, don't do that, it's a waste of time. I mean, if you want to. Anyway, I hope you have a nice day, so later.